Hello everyone, welcome to this video. In this video, let's solve this question which states that suppose H is a proper subgroup of the group of integers under addition, right? So it consists of all the integers, this group, and the group operation here is addition, right? So they say if we are taking H as some proper subgroup of this group Z such that it contains these three numbers 18, 30 and 40, we need to find what is the given subgroup. What other elements does it have, right? So this is the question here. For this particular question, we have our H like this. Now, you know, for H to be a subgroup, for this H to be a subgroup, we should have these properties with us, right? The group axioms, it should be satisfied by our subgroup as well. So that means the identity element should be there here, the closure property should be there, and the inverse of each element, it should also be there in H, right? Now under addition, what is the identity element? If you see and if you remember, the identity element is 0. Why? Because if you add 0 to any integer, you would get back the same integer, correct? So this is the identity. So this definitely has to be present in H. What about the inverse of each element? So this property has been done. For the inverse of each element, we are looking for those elements here such that they give us the identity, right? So you see, it is the negative of that particular integer. So for 18, if you add minus 18 to it, you will get back 0. So that means this minus 18 should also be present in your H. Similarly, for 30, you should add minus 30 to it to get back the identity element, right? So this should also be there in H. Similarly, you have 40. When you add minus 40 to it, you should get back 0, which is the identity element, right? So this minus 40 should also be there in this particular case, right? So therefore, as I told you, so at least this is our H, right? It may contain few more elements as well. Let's now check about this closure property. Closure property says if you take any two elements from this set H and then apply the group operation, which is addition, you would have some member which should also be there in H according to the condition that H is a subgroup, right? So if you take any two elements from it, suppose let's take this 30 and minus 18, so you get 12. So 12 is not present here, but it should be present in H. So 12 should be present in H. Now its inverse should also be there, so minus 12 also should be there in H. Similarly, if you take any two other elements, let's take plus 18 and which element? This newly found element 12. So you obtain 6 here. So minus 6 and 6 both should be there in H. Similarly, if you take some other element, say you take 30 and you take this newly generated element 6, so you obtain 24, which was already not present in H, but now it is. Next, if you have some element plus 40 here and 6 is with you, then you have 34. In similar manner, this is the most basic way to find various elements of this subgroup, right? In this way, you can find various elements from this subgroup. By checking the closure property, you can keep on doing like this. You can apply on to various combinations. Now there are infinite combinations. If you go on finding it, it would take forever. But this is how you can initiate your process, right? You can have some idea about your subgroup H if you don't know the actual result. So you see, we have all the members of this kind: minus 12, 12, minus 6, 6, minus 24, 24, minus 34, 34, minus 10, 10, minus 20, 20, minus 14, 14, minus 8, 8, minus 4, 4, and so on, right? So you see, we can continue like this, and you can finally, generalizing the result, you can conclude that all the even integers of Z which are already present in Z, they are also present in H. So that means if you multiply it with 2, so whatever is the result, that is your H, right? So all the even integers are present in H. Why? Because if you see, by taking any two even numbers, you cannot obtain any odd number. So in this case, this is the result. So Another thing, if you notice here in this case, if you calculate the greatest common divisor of these three members, 18, 30 and 40, it came out to be 2. So you see, by this 2 you can generate each member of H, right? Each member of your subgroup H. So that means you can write your H as the 2z, which is consisting of all the even integers, right? So this is how you can solve this question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.